So in this video, we will talk about DNP3 protocol. So let's try to understand what is DNP3 protocol and how we utilize it. So DNP3 protocol is nothing but the distributed network protocol version 3, which is an open protocol used between components in process automation systems. It is based on enhanced performance architecture, that is EPA. So EPA we discussed when we were discussing IEC 60870-5 protocol. So DNP3 is also based on EPA model. It is primarily used for communications between master station and IDs or the RTUs. It supports multiple slave, peer-to-peer and multiple master communications. DNP contains application and data link layers with pseudo transport layer. So the architecture we will discuss in future slides so that you can understand what are the various layers we have in DNP3 protocol. So DNP3 protocol is simply encapsulated within the TCP/IP. The widely used variety of physical layers in DNP3 protocols include the RS-232, RS-422, RS-485 as well as the physical layer of TCP/IP. Now the DNP3 protocol contains the pseudo transport layer, which is nothing but the layer 4 of OSI layer and used to build the application data messages larger than the single data link frame. It uses FT3 frame format. It can request and respond with multiple data types in single messages. DNP3 segments the messages into multiple frames to ensure the excellent error detection and recovery. It is designed to optimize the transmission of data acquisition information and control commands from one computer to another computer. It supports the response without request, that is unsolicited request. It provides interoperability between different vendors' equipment because it is considered to be an open and standard protocol. The DNP3 protocol provides multiplexing, data fragmentation, error checking, link control, prioritization, and the layer 2 addressing services for user data. However, the DNP3 is not designed to be secure from attacks by hackers. Why? Because the DNP3 was designed when the cybersecurity concept was not there in the IT domain. The DNP3 protocol layers, if you see, this is your OSI 7 layer model where we have physical data link, network, transport, session, presentation, and application layers. While in case of DNP3 protocol, the DNP3 protocol is based on enhanced performance architecture, that is EPA. So 3 layers are from EPA. On top of that, we add pseudo transport layer which have limited transport and limited network capability. So the pseudo transport layer allows the transmission of large block of data. How? That we will see in the next slide. The network functions for routing and flow control of data packets over networks are ensured by this pseudo transport layer. The transport functions in the pseudo transport layer provide the network transparent end-to-end delivery of messages. Disassembly and the reassembly of the data and error correction of messages are possible because of the inclusion of pseudo transport layer. Now, how the message build up happens in DNP3 protocol. Suppose there is a user application which is sending the data which is large in size. So what will happen at the application layer, this large size data will be divided into multiple ASDUs, that is application service data unit, where the data fragment will reside, and then you have application layer protocol control information block, which is like a header of the ASDU. So this will be a complete APDU, that is application layer protocol data unit. The size of APDU is limited to 2048 bytes. Now this APDU, when it travels to the transport layer, it becomes TPDU, but the size of TPDU is 250 bytes. So what we have to do, the APDU which we get from the application layer has to be fragmented into blocks of 250 bytes. So here the transport header will be added, and the transport header size is 1 byte. Then rest 249 bytes are the data units. So total 250 bytes will be the one transport layer protocol data unit. So these fragments will now be traveling to the link layer. So at link layer, frame will become link layer protocol data unit, which has the size of 292 bytes. So 250 of data, that is transport layer protocol data unit, plus 32 bytes of CRC, that is cyclic redundancy check bytes, and 10 bytes of link layer headers are added. So in this way, the 250 bytes of TPDU will become 292 bytes of LPDU. Now this 292 bytes of LPDU are sent to the physical layer for actual data transmission. So in this case, depending upon the type of physical layer communication we are using, it will be further subdivided into multiple packets. So generally we have 8-bit data packet with one start bit and one stop bit. So it will be further fragmented and the data will travel. The reverse exercise is taken care by the receiving end, where the various data packets are stitched together and the information is retrieved by the application at the receiving end. Now the DNP3 protocol frame format. So we use FT3 frame format at the link layer level, where the size of the link layer protocol data unit is 292 bytes. So first block of the frame is the header frame, which is of 10 bytes. Then we have 16 blocks of data. So user data is of 16 bytes plus 2 bytes of CRC, and the last block, that is the 16th block, will have user data of 10 bytes and the CRC of 2 bytes. So in this way, the size of total link layer protocol data unit becomes 292 bytes. Now in 10 bytes of header, the information which is provided is as follows. We have 2 bytes for start of the frame. Length of 1 byte contains the count of the user data in bytes. Control byte is the frame control byte. Destination section is of 2 byte, which stores the destination address, and the source will contain the 2 byte of source address, and then 2 byte of CRC, that is cyclic redundancy check code, is embedded. So in this way we have 10 byte of header. Now the DNP3 message communication. So in case of DNP3, we see the balanced data communication. That means master as well as slave can initiate the primary data frame. So master station will send the request frame to the slave. Slave will confirm through acknowledgement, and then slave will start sending the data, and in return the master will confirm the receipt of the data. So in this way the message communication happens between master station and slave station. Some important things to consider in case of the message communications are as follows. In SCADA, Some stations may be identified as master stations and some other as the slave stations. So generally the RTUs are considered to be a slave stations and the control center servers are considered to be master stations. So there may be some devices which can act both as slave station as well as master stations. So master slave distinction will be applicable only at the application layer level, while in data link layer we generally talk about the balanced as well as unbalanced data communication. In case of unbalanced system, only master station will initiate the communication. Since in case of DNP3 the initiation can happen from master as well as slave, so that's why the DNP3 supports the balanced data communication only. So at the link layer we will see only the balanced data communication to provide the greater flexibility by allowing non-master station also to initiate the communications. In DNP3 any station can be the originator of primary station, which not necessary to be the master station. So primary station means the station which starts sending the primary data frame. Here the term master slave used at the link layer level for setting the message direction bit. So as we saw in case of IC 60870-5-101, the message direction, that is the controlling message or the controlled message, are defined. In the same way, the direction of the message can be set using the direction bit. Now when we compare the DNP3 and IC 60870-5-101, DNP3 is open standard and IC 60870-5-101 is also open IC standard. DNP3 is mostly dominating in North America while 101 is dominating in Europe. The DNP3 is based on 4-layer architecture which supports TCP/IP as well, while 101 is based on 3-layer EPA architecture and does not support TCP/IP. In DNP3, messages are encapsulated in the data link frames, as we saw in case of the DNP3 data frame creation at various layers. The application layer protocol data unit is further subdivided at transport as well as data link layer to create the various smaller packets or frames of the data set. In that way, large application data can be sent to the receiving station in one go. While in case of 101, the application functions are specified at the data link layer level. In case of DNP3, the application layer message consists of many data link frames because we fragment the data at transport as well as data link layer level into multiple data frames. While in case of 101, since we do not have transport layer, we cannot fragment the data. So in that way, message which the application layer is sending has to address this limitation. In that case, the application function will require to send the message in multiple chunks so that it can be stitched together at the receiving end. In DNP3, we have only the balanced data communication, while the 101 can have both balanced as well as unbalanced data communication. In case of DNP3, the pairs of devices may swap the role of master and slave, while in case of 101, pairs of devices cannot swap the roles of master and slave. The DNP3 is based on FT3 frame format, while the 101 is based on FT 1.2 frame format.